Hello everyone, and welcome back to the Fluctus channel. Beach landing is the most dangerous and logistically complicated operation a military can attempt, mainly due to the fact that it involves bringing a wide range of troops, supplies, and vehicles ashore while facing constant enemy fire. Operation Overlord, otherwise known as D-Day, is a great example of beach landing. Almost 160,000 troops crossed the English Channel into France, supported by 5,000 ships and 1,200 aircraft. The most important factor throughout this operation was the ability of the troops to get safely from the ships to the beach. Over the years, several amphibious vehicles have been procured and used for amphibious assault. However, the most extraordinary amphibious vehicle ever built is the 8-wheeled amphibious combat vehicle. According to the U.S. Marine Corps, the ACVs will replace its aging amphibious assault vehicles, which date back to the early 1970s. The ACVs provide 3 times the force protection capability of the AAV and ramped-up horsepower, allowing it to travel at speeds of up to 65 miles per hour on paved roads and almost 6 knots on the water. The ACV weighs 35 tons and is capable of carrying 15 personnel at a time. ACV is a fairly new platform, and the Marines had to undergo extensive training to operate it in the ocean. The Marines got in and out of the ACV's entry and exit points to determine the best way to evacuate in case they found themselves in distress in the middle of the ocean. Initially, the Marines operated the ACV on land, but later they launched it into the water and moved it safely through the surf zone. The ACVs are launched into the water from modern warships, equipped with well decks situated at the rear. These well decks are periodically filled with water to launch, recover, and accommodate up to 52 amphibious vehicles at a time. The well deck control officer gives the order via radio to launch an ACV into the water. The ACVs roam out of the well deck while floating on the water and ultimately land on shore. Once the Marines complete their objectives, the ACVs return back to the warship. The well deck is again flooded with water so the ACV can smoothly enter and park inside the ship. The ACV is fully capable of defending itself in the water, as it's equipped with extraordinary armament, including a 30mm cannon, which is effective against enemy lightly armored vehicles, fortified bunkers, helicopters, and fixed-wing aircraft. Additionally, the ACV is equipped with a .50 caliber machine gun in a remote weapon station, along with a grenade launcher turret. On May 4, 2024, the U.S. Marine Corps conducted a waterborne live-fire exercise at Oyster Bay, Philippines. It allowed them hands-on experience with the ACVs weaponry and amphibious operations. The ACVs provide exceptional armor protection, which allows them to perform beach landing while taking heavy fire from the enemy on the other side. Moreover, they are equipped with wheels instead of tracks, which makes them a better option for ground missions. Once the Marines are on the ground, the ACVs can also be used as barriers to get protection from enemy attacks. This capability allows the Marines to calculate their approach of retaliating and securing the beach, giving them the edge against the enemy. ACVs are man-made machines, and it's possible for them to malfunction during waterborne operations. Therefore, if an ACV is stranded in the middle of the ocean due to malfunction, it is retrieved back to the well deck using another ACV. The Marines attach the malfunctioned ACV to the functioning one using ropes. It's then towed back to the warship. The Marines train for such scenarios both day and night to be fully prepared if something like this occurs in combat. Several developments have occurred in amphibious vehicles over the years. However, the Landing Craft Air Cushion, or the LCAC, revolutionized amphibious operations entirely. LCAC is monitored by a crew of 5 and is capable of operating from all amphibious well-deck ships like LHA, LHD, LSD, LPD, and ESD. The LCAC is equipped with air cushion technology, which allows it to reach more than 70% of the world's coastline, while only 15% of that coastline is accessible by conventional landing craft. Before it's launched from a well deck, the side skirt of the LCAC is inflated to create a cushion of escaping air upon which the aircraft rides. It's then launched into the water by following instructions of the well deck control officer.
10 degrees to the stop. They're lowering it to 90 and a little bit lower.
LCAC is 87 feet long and 47 feet wide, and can carry up to 75 tons of equipment at speeds of more than 40 knots. It features a large ramp at the front side, which allows trucks, Humvees, and other vehicles to simply drive up for transport from ship to shore and vice versa. In fact, it can make multiple runs back and forth to deliver and retrieve multiple vehicles at a time. Due to its air cushion technology, the LCAC can drive directly onto a beach or other landing zones. Upon reaching land, the LCAC lowers its ramp to offload equipment, troops, and vehicles. The LCAC can drive further into the land, equally traveling other rivers, lakes, mud, and concrete. The U.S. Navy and the U.S. Marine Corps always prioritized putting time, money, and effort into advancements in naval technology. In 2017, they conducted the Ship-to-Shore Maneuver Exploration and Experimentation Advanced Naval Technology exercise at Marine Corps Base Camp Pendleton, California. The Marines field tested more than 50 different new technologies, from swarming unmanned surface vessels to self-driving amphibious assault vehicles. Field testing was performed for various mission areas, including early reconnaissance, threat identification, threat elimination, and maneuver ashore. The technologies that performed exceptionally graduated to a more formal operational evaluation for further testing. The S2ME2 heavily focused on unmanned aerial systems, which could provide intelligence, surveillance, and reconnaissance on the battlefield. These are critical missions that have been traditionally performed by sailors, Marines, and special operators, but it put them at extreme risk. Drones were tested during the S2ME2 to make the amphibious assault more effective in the future. The Marines found a unique way of launching the drones into the air. Special unmanned launchers emerged from the AAVs and launched the drones into the air to perform ISR operations.
Why are we doing this? Because we want to get better. And the world has changed. Our adversaries are gaining capability, and we don't want a fair fight. And so we're always looking for an edge, because I don't want to put you or any other Marine in a fair fight.
In addition, the Marines tested a unique vertical takeoff and landing drone to improve aerial support. This kind of intelligence provides an edge to the U.S. armed personnel on land against the enemy. The VTOL drones have the ability to take off and land vertically, making them highly versatile for use in naval operations. Moreover, these drones are equipped with advanced radar systems, which provide enhanced situational awareness, allowing the Marines to detect and track targets from long distances. The beach landing ability of the ACV and LCAC, along with emerging technologies, are vital for enhancing U.S. naval capabilities. ACV is a fairly new technology that improves both attack and defense capabilities during beach landing, while LCAC ensures swift transport of equipment and vehicles to shore. Furthermore, integrating advanced technologies like drones allows the United States to adapt to modern threats and enhance situational awareness. Together, these elements enhance amphibious operations, ensuring the U.S. Navy and the U.S. Marine Corps have a decisive advantage in a combat environment. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.